Good morning to one and all for the today's session. So I welcome you all for the today's session for metal cutting and forming. That is first module. Today I will be dealing with semi-automatic and automatic lathe. Okay, automatic lathe, semi-automatic and automatic lathe. Okay, general purpose machines tools may have both fixed automation or flexible automation, where the latter one is characterized by CNC, that is computerized numerical controlled machine, that is nothing but CNC. Conventional machines, general purpose automated lathes can be conventional general purpose automated lathes can be classified as follows. There is one is semi-automatic. In that, under semi-automatic, this capstan lathe and turret lathe comes. Capstan lathe, multiple spindle turret lathe, coping or hydraulic lathe, and B, that is automatic cutting of lathe, single spindle automatic lathe, switch type automatic lathe, and multiple spindle automatic lathe version. In contrast to center lathes, capstan and this you all can see in the figure, capstan and turret lathes are semi-automatic, okay, which possess an axial movable indexable turret, mostly hexagonal, in place of tailstock, holds large number of cutting tools up to 4 in indexable tool post in front side and 1 in rear side, and up to 6 in turret as shown in figure. Here you will be seeing in the figure turret lathe, and these are more productive for quick engagement and overlapped function of tools, in addition to faster mounting and feedings of job, and rapid speed change will be occurring in this. Okay, and then these are relative costlier and also suitable and economical viable for batch productions. Okay, difference between the capstan lathe and this turret lathe you all can see. Okay, difference between this capstan lathe and turret lathe. These turret lathes are more robust and heavy duty machines, and capstan deal with short or long rod type blanks held in collet. Okay, whereas turret work on chucking type jobs held in quick acting chucks, and in capstan travels with a limited stroke. In this capstan lathe, turret travels with limited stroke length, okay, within a saddle type guide block called auxiliary bed, which is clamped on a main bed, as whereas in turret lathe the heavy turret in turret lathe the heavy turret being mounted on a saddle, which is directly slides with larger stroke length on main bed as shown in figure. You all can see the guide rod over there. One additional guide rod or a pilot bar is provided on headstock or turret lathe as shown in figure. External screw threads are cut in capstan lathe if required, using a self-opening die being mounted in one face of turret, whereas in turret external threads are generally cut if required by single point or multi-point chasing tool being mounted on front side and moved by shorter lead screw and swing type half nut. Okay, so next we'll be dealing with ram of capstan lathe. These are the rams of capstan lathe. You all can see the hexagonal. I have already, as I said, it will be a movement of hexagonal. Okay, as I said in the beginning itself, I have told you all that is hexagonal. So that is, these are hexagonal turret, and this is the ram, feed, stop rods, lathe bed, saddle clamp to the bed, and hand wheel with which we can rotate. Okay, and saddle of turret lathe. This is the saddle of turret lathe with hexagonal turret. Remember that if turret lathe comes, it means it indicates hexagon. Okay, turret saddle. This is the bed and hand wheel. Okay, and pictorial view of capstan lathe. Capstan lathe you all can see here. How will be the capstan lathe? Okay, this is used for mass productions. Most probably this is used for mass productions, or you all can say batch productions, or lots of more productions where more number of production is done. These are used. Okay, pictorial view of turret lathe. Turret lathe, these are used for heavy duty. Turret lathes are used for heavy duty jobs. Okay, like chucking, chucks, manufacture of chucking and chucks, all this comes under this. Multi spindle turret lathe. Turret lathes are mostly horizontal axis, single spindle type. The multiple spindle vertical turret lathes are characterized by suitably used for large lot of mass or a lot or mass productions of jobs of generally chucking type, relatively, as I said, chucking type, relatively large size, requiring a limited number of machining operations, machine axis, or vertical for lesser floor space occupied, easy loading and unloading of blanks and finished jobs, relieving the spindles of bending loads due to job weight. Number of spindle, that is 4 to 8. How many spindles are there in multi spindle? 4 to 8. 4 to 8 spindles are available. And next one is hydraulic coping lathe. Hydraulic coping lathe or it is also called as tracer controlled lathe. Jobs having steps, taper, you all can see this. Jobs having steps and taper are or curved for profiles as typically as shown in the figure. Okay, are conveniently and economically produced in batch or lot in semi-automatically operated tracer controlled or hydraulic coping lathe. The movement of stylus along the template provided with the same desired job profile, okay, is hydraulically transmitted to the cutting tool tip, which replicates the template profile. Okay, next we are going to deal with automatic lathe. Automatic lathes are essentially used for large lot of mass production or small rod type of jobs. Automatic lathes are also classified into following things, that is single spindle automatic cutting of lathes, automatic screw cutting lathes, switch type automatic lathe, and multi spindle automatic lathe. In automatic cutting of lathe, these are simple but automatic lathes are used for producing short work pieces of simple form by using few cross feeding tools. In addition to parting, some simple operations like short turning, facing, champering, etc. are also done here. Automatic cutting of machines. You all can see here. These are the automatic cutting of machine. Okay. And next, we will be dealing with single spindle automatic lathe. The general purpose of single spindle automatic lathes are widely used for quantity or mass production by machining of high quality fasteners like fasteners like bolts, screws, studs, etc., bushings, pins, shafts, rollers, handles, and similar small metallic parts from long bars or tubes or regular section. Okay, so you all can see in the figure typical single spindle automatic lathe. Okay, this is a single spindle automatic lathe. In this, what they have shown, preferably and essentially used for larger volume production, like large lot of production or mass production. This is used single spindle automatic lathe. And run fully used always for producing jobs of rod, tubular or ring type and or smaller size like as I said fasteners and studs, screws. All such jobs are manufactured with the help of this machine. Okay, and also it is provided with up to 5 radial tool sides which are moved by cams mounted on camshaft. Cams mounted on camshaft. You all can see the camshaft here. Cams are mounted the camshaft. Okay, these are the cams. These are the on the camshaft. The cams are mounted which can slide over them or move here and there. Okay, these are the things they have told. And next, pictorial view of single spindle automatic lathe. This is the automatic screw cutting machine. Okay, huh? Swiss type. Next is Swiss type automatic lathe. Characteristics and applications of these single spindle automatic lathes. Diameter range 2 to 12 mm, length range 3 to 30 mm, and these are used for a lot of mass production of thin slender rod, tubular jobs like components like small clocks, wrist watches by precision machining job sizes. Okay, dimensional accuracy and surface finish almost are good as provided by grinding. In respect to the configuration and operation, the headstock travels enabling axial feed of the bar, axial feed of the bar stock against the cutting tools as indicated in the figure. There is no, you all can see in this figure. Okay, huh? The sliding headstock and the bar stock, as I said, tool bracket. You all can see this. Huh? With the help of the headstock travels enabling axial feed of bar stock against the cutting tool. Against the cutting tool. Remember this, against this cutting tool I have told you. There is no tailstock or turret. High spindle. See here, there is no tailstock or turret over here. There is no tailstock in this machine or turret. Okay. The cutting tools are fed radially. Drilling and threading tools, if required, are moved axially using swelling device. Using swelling device. Okay. The cylindrical blanks are pre-finished by grinding and are moved through a carbide guide bush as shown. Okay. Next are the basic principles of Swiss type automatic lathe. So these are the job guide, headstock, tool side, radial, which is radial, rocker arm you all can see, cutting tool positions and motions as has been shown. Okay, and this is the job which is holded. The help of this job guide. Job guide is at the top and bottom of the job, and it is folded properly or uh, locked properly. You all can see multiple spindle automatic length for further increase in rate of production of jobs, usually of smaller size and simpler geometry. Multi spindle automatic lathes having 4 to 8 parallel spindles are preferably used. These are horizontal for working on long bar stocks, work mostly on long bar type of tubular blanks. Okay, parallel action multiple spindle automatic lathes. You all can see this is parallel. It is shown in the parallel, the front tool side and rear tool side. You all can see. And work spindles are, see the work spindles. How many are there? 1, 2, 3, 4. 4 work spindles are there in between. Okay, so parallel action and multi spindle automatic machines are this type, and progressive action multiple spindle machines are these. Okay, next progressive Yolkin processing type, the spindle carrier with the blanks fitted in the chucks on rotating spindle is indexed at regular interval by Geneva mechanism. Geneva mechanism, you all can see this in this figure itself, it indicates that is Geneva mechanism. As you have studied in the previous semester in kinematics of machines, that is you have studied in first module, that is Mechanisms. In mechanisms, Geneva mechanisms. This is similar to Geneva mechanism, this progressive action and multiple spindle mechanism machines. Okay, at each station the job undergoes a few preset machine work by the axial or radial fed cutting tools. The blank getting all the different machining operations progressively at the different workstations is unloaded. You all can see that at the different workstations the job is unloaded or indexed. Huh? Understood? Now I will use this machining time and estimation. You all can see TC is equal to LC by N suffix S of O into N suffix P. L suffix C is equal to actual length of cut, that is equal to L plus A plus O. A and O is approach and overrun as shown. N is spindle speed, R in RPM, that is. S suffix O is feed, that is in mm per revolution. N suffix P is number of passes required. Okay, V suffix C is pi d n by 1000 meter per minute. D is equal to diameter of the job before cut. Before cut, remember, listen carefully. Capital D is diameter of the job before cut. Then N is equal to 1000 V suffix C by pi D. Therefore, N suffix P is equal to D1 by minus D2, D1 minus D2 by 2T. Problem 1 will take. How much machining time will be required to reduce the diameter of the cast iron rod from 120 mm to 116 mm over length of 100 mm by turning using a carbide insert? Reasonably select values of V suffix C and S suffix O. What is V suffix C? That is velocity. Okay. And S suffix O is feed, that is in mm per revolution we have to find here. For turning Ci by carbide inside, V suffix T is taken as 100 meter per minute and S suffix O is 0.2 mm per revolution. So what we have to find, how much machining time will be required. Time we are going to find T suffix C is equal to L suffix C divided by N S suffix O for single pass. L suffix C is equal to 100 plus 5 plus 5, that is 110 mm. So N is equal to 1000 into V suffix C by pi D. So for turning cast iron by carbide insert, V suffix T is taken as 100 meter per minute and S suffix O is 0.2. Therefore N is equal to, substitute the values in the formula. N is equal to 1000 into 100 divided by pi into 120. Pi into 120, diameter D is 120, that is equal to 250 rpm. Nearest standard speed N is equal to 225. Therefore TC is equal to 110 by 225 into 0.2, that is 2.5 minute. Okay. Problem 2. Okay, we'll be discussing problem 2. Determine the problem 2. We'll take problem 2. Determine TC for plane milling rectangular surface of length 100 mm and width 50 mm by helical fluted plane HSS milling cutter of diameter 60 mm and length 75 mm and 16th. Assume A is equal to 0, A is equal to O is equal to 5 mm, V suffix C is equal to 40 minutes per minute and S suffix O is 0.1 mm per tooth. Mm per tooth. T suffix C is equal to L suffix C divided by S suffix M in minutes. L suffix C is equal to L suffix W plus A plus O plus DC by 2, that is equal to 100 plus 5 plus 5 is plus 30, that is 140 mm. Okay. S suffix M is equal to S suffix O Z suffix C N, that is 0.1 into 6 into N. N is equal to 1000 V suffix C by pi DC, that is equal to 1000 into 40 divided by pi into 60, that is 200 rpm N. Substitute the values in the formula S suffix m. 0.2 into 6 into 200, that is equal to 120 mm per minute. Therefore Tc is equal to Lc by Sm, that is equal to 140 by 120, that is 1.17 minute. You got it. Okay, with this we complete this. Okay, thank you for the today's session. If you have any doubts, you can